Hi guys, welcome to today's video where we will be treating grade 11 Newton's Laws 2015 November question paper. Let's get to it. The problem statement reads as follows. A constant force F pulls a 50 kilograms block at a constant speed over a rough horizontal surface AB as shown in the diagram below. The coefficient of kinetic friction mu k between the block and the surface is 0.4. 3.1. Draw a labeled free body diagram showing all the forces acting on the block. And the free body diagram will be as follows. I will have a total of 4 forces: applied force, frictional force, force of gravity, normal force. But in my diagram, notice that I have more forces, 5 to be more specific, because I broke my applied force into 2 components, Fx and Fy, vertical component and a horizontal component, because that force is applied at an angle. 3.2. State Newton's first law of motion in words. Newton's first law of motion states that a body will remain in its state of motion until a net force acts on it. Moving on to 3.3. Calculate the magnitude of force F. Here I know that I will have to apply Newton's second law of motion. And doing that, I get F net is equals to mass multiplied by acceleration. I've kept my free body diagram on the far right corner, as you can see. Next, I'm gonna calculate for F net, or find F net. And I know that F net is found along the direction of the motion. That is the horizontal direction. And horizontally, I know that, or I noticed from my free body diagram, that I have 2 forces, namely Fx and Fr. And I'm choosing the direction of the motion as positive, which is right, and hence right will be positive and left will be negative. Fx minus Fr is equals to ma, because Fx is positive as it's acting along the direction of the motion, and Fr will be negative because it opposes the motion. Substituting in the formulas, I get F cos of theta, because I know that the horizontal component of the force is represented by F cos of theta, minus friction. I know that friction is coefficient of friction multiplied by normal force, and I notice that my normal force will be equal to force of gravity minus vertical component of the force, and hence Fr is equals to mu multiplied by Fg minus F sine of theta, and they are all equals to mass multiplied by acceleration. Now substituting in the values, I get F cos of 20 minus 0.4, 50 times 9.8 minus F sine of 20 is all equals to 0. Simplifying, or now getting rid of the cos of 20 and the sine of 20 to clean up my equation a little bit, I get 0.94F minus 0.4 multiplied by 490 minus 0.34F is equals to 0. And now multiplying the 0.4 into the bracket, I get 0.94F minus 196 plus 0.14F is equals to 0. And making F subject of the formula, I get 0.94F plus 0.14F is equals to 196. And hence I'll have 1.08F is equals to 196, and dividing both sides by 1.08, I get an F value of 181.48 newtons. 3.4. Calculate the magnitude of the normal force. I have in a way already calculated for normal force during this question, but in case you missed it here because everything is so complicated, let's do it afresh. I know that this box is not moving up or down, it's only moving to the left and right, and hence that means upward forces equals to downwards forces. They balance each other out, and hence it will not move up and down, and that is normal force plus Fy. That is, the upwards forces are equal to downwards forces, which is the force of gravity. Now making N subject of the formula, or normal force the subject of the formula, I will get N is equal to Fg minus Fy. And substituting in the formulas, I get N is equal to Mg minus F sine of theta. And substituting in the values, I get N is equal to 50 times 9.8 minus 181.48 sine of 20. That will give me an N value of 427.93 newtons. 3.5. Calculate the magnitude of the frictional force. Again, I've already in a way calculated for frictional force in 3.3, but because everything was so complicated there, let's break it down nicely on a clean slate. I know that the box is moving at constant speed, and hence acceleration is 0, and that will mean forward forces are equal to backward forces, and hence frictional force is equal to Fx, or the horizontal component of the force. And substituting in the formulas, I get Fr is equal to F cos of theta, and substituting in the values, I get Fr is equal to 181.48 cos of 20, and hence Fr is equal to 170.54 newtons. 3.6. The same constant force F is now applied to the block over the same rough horizontal surface as before, but in the direction shown below. Give a reason why the block will move slower than before. Simple. The vertical component of the force will be facing downwards, increasing the normal force, and hence frictional force will also increase as it is directly proportional to normal force. And that concludes question 3. Moving on to question 4. 4.1. In the diagram below, a 2 kilograms block is connected to a 1 kilograms block by a means of a light inextensible string. The blocks are pulled up an inclined plane, which forms an angle of 28 degrees to the horizontal. The sides of the block which touch the inclined surface have the same area. The kinetic frictional force between 1 kilograms and the inclined plane is 4 newtons, while the kinetic frictional force between the 2 kilograms block and the inclined plane is 8 newtons. 4.1.1. Draw a labeled free body diagram showing all the forces acting on the 1 kilograms block. And the free body diagram is as follows. I have force applied, normal force, Fg parallel, Fg perpendicular, Fr, and tension. 4.1.2. State Newton's second law of motion in words. Newton's second law of motion states that when a net force acts on an object, the object will accelerate in the direction of the force, and the acceleration is directly proportional to the force and inversely proportional to the mass of the object. 4.1.3. Calculate the magnitude of the tension in the string connecting the blocks. I know that I have to apply Newton's second law of motion in each individual block. And starting with the 2 kg block, I'm gonna go on and say F net is equal to MA. And on the 2 kg block, I notice that I have 3 forces that are along the motion of the object. And that is the tension, Fg parallel minus Fr, and they are all equals to MA. Tension is positive because it's moving on the direction of the motion. Fg parallel is down the incline, and Fr is also down the incline opposing the motion, and hence they will be negative. And that will give me an equation of T minus Fg parallel minus Fr all equal MA. Now substituting in the formulas, I get T minus mg sine of theta because I know that Fg parallel is given by mg sine of theta minus friction, which is 8. I was given by the problem statement is equals to 2a because the mass is 2 and the acceleration I don't know it. And now substituting in the values, I get T minus 2 times 9,8 sine of 28 minus 8 is equals to 2a. And now making acceleration subject of the formula, dividing both sides by 2, I get T minus 2 times 9,8 sine of 28 minus 8 all divided by 2. And I'm gonna go on and call that equation 1. Moving on to the 1 kg block. Again, applying Newton's second law, F net is equal to MA. And I notice that in the 1 kg block, there are 4 forces that are along the direction of the motion. That is force applied, tension, friction, and Fg parallel. But the only force that is on the direction of the motion is force applied. This time around, the T is negative because it opposes the motion. And hence I'll have Fa minus T minus Fr minus Fg parallel is equals to MA. And substituting in the formulas, I get 30 minus T minus 4 minus mg sine theta is equals to 1A. And substituting in the values, I get 26 minus T because 30 minus 4 is 26 on the previous formula. And hence I'll have 26 minus T minus 1 times 9,8 sine of 28 is all equals to A. And making A subject of the formula, I will call that equation 2. Now, I notice that I have 2 equations, and the subject of both formulas is A, acceleration. Because the string is light and inextensible, the acceleration of box 1 is equal to the acceleration of box 2, and hence equation 1 is equal to equation 2. Equating the 2 equations, I get T minus 2 times 9,8 sine of 28 minus 8 over 2 is equal to 26 minus T minus 1 times 9,8 sine of 28. And cross multiplication, I get 2 multiplied by 26 minus T minus 1 times 9,8 sine of 28 is equal to T minus 2 times 9,8 sine of 28 minus 8. And multiplying the 2 on the left hand side of the equation, I get 52 minus 2t minus 2 times sine minus 2 times 9,8 sine of 28 is equals to t minus 2 times 9,8 sine of 28 minus 8. And making t subject of the formula, I get negative 2t minus t is equals to negative 2 times 9,8 sine of 28 minus 8 minus 52 plus 2 times 9,8 sine of 28. And looking at that equation, I noticed that negative 2 times 9,8 sine of 28 plus positive 2 times 9,8 sine of 28 will cancel each other out, making 0. And on the right hand side, I will only be left with negative 8 minus 52. And hence, I will have this equation. Negative 3t is equals to negative 6t. And dividing both sides by negative 3, I get a t value of 20 newtons. And I've answered the question. I've calculated for tension. The two blocks are interchanged, so the same 30 Newton force is acting on the 2 kilograms block along the inclined plane as shown in the diagram below. 4.1.4. How will the acceleration of the system change? Write down only increase, decrease, or remain the same. Because everything is still the same and the string is light and inextensible, it will remain the same. 4.1.5. How will the tension in the string connecting the two blocks change? Write down only increase, decrease, or remain the same. Here, we notice that on the first diagram, the 2 kg block was the one pulling down the tension. And the 2 kg block is larger than the 1 kg block. And hence, it will apply a larger force than the 1 kilogram block. Because now the block applying the tension or the force is smaller, this will result in a decreased tensional force. And hence, the tensional force will decrease. Moving on to question 4.2. The problem statement says, in the diagram below, a 1 kilograms mass and a 2 kilograms mass are connected by an inextensible string of negligible mass. The string is passed over a light frictionless pulley so that the mass hang down as shown. Initially, the system is held stationary. 4.2.1. Draw a labeled free body diagram showing all the forces acting on the 2 kilograms mass. And the free body diagram is as follows. It's just two forces, tension and force of gravity. 4.2.2. Calculate the time it will take the 1 kilograms mass to move a distance of 1 meter when the system is released. Because the problem statement says something about time, I know that at one point of solving this problem, I'll have to introduce equations of motion. But first things first, we start by applying Newton's second law of motion, which states for 1 kilograms block, F net is equals to ma. And for 1 kilograms block, it moves upward, and I'm gonna choose upward as positive direction of motion and downward as negative, and that will give me an F net of t minus fg, and they are all equals to ma. Substituting in the values, I get t minus 1 times 9,8 is equals to 1a, making t subject to the formula, I get t is equals to a plus 9,8. Moving on to 2 kilograms block. Again, F net is equals to ma. This time around, the block is moving downwards, the 2 kilograms block. And hence, I'm going to choose downward as positive for this particular block. And applying the law, Fg minus t is equals to ma. T is negative now because it opposes the motion. And substituting in the values, I get 2 times 9,8 minus t is equals to 2a. And making t subject of the formula, I get t is equals to 19,6 minus 2a. And that is my second equation. Again, the string is inextensible, and hence tension of 1 kg block is equals to tension of 2 kilograms block, and hence the first equation is equals to the second equation, and equating the equations, I get a plus 9,8 is equals to 19,6 minus 2a, and making a subject of the formula, I get 3a is equals to 9,8, and hence acceleration is equals to 3,27 meters per second squared. Now that I have the acceleration, I know that I have acceleration, I have initial velocity, it was 0 because the system was stationary. I have change in y as 1 meter, and change in time, that's what I'm asked to find. And I'm gonna go and take a look at 4 equations of motion and choose one that has acceleration, initial velocity, change in y, and time. And that equation will be this one. Change in y is equals to vi change in time plus 1 over 2 acceleration change in time squared. Substituting in the values, I get 1 is equals to 0 because initial velocity was 0, hence 0 multiplied by time will be 0 plus 1 over 2 3,27 change in time squared. And simplifying that a little bit further, I get 1 is equals to 1,635 change in time squared, and dividing both sides by 1,635, I get change in time squared is equals to 1 over 1,635, and hence change in time is equals to square root of 1 over 1,635 and change in time will be 0,78 seconds. And now I am done, and that concludes question 4. Let's move on to question 5. Gravitational force exists between the sun and the earth. 5.1. State Newton's law of universal gravitation in words. Newton's law of universal gravitation states that each body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. 5.2. The mass of the sun is 330,000 times greater than that of the earth. The distance between the centers of the sun and the earth is 1,38 times 10 to the power 9 meters. Calculate the gravitational force that the sun exerts on the earth. I know that the formula is F is equal to GME, mass of earth multiplied by mass of sun, all divided by R squared. And I know that the G is the gravitational constant, which is equal to 6,67 times 10 to the power negative 11. That value is also there on your formula sheet. And I know that the mass of sun is equal to 5,98 is equal to 5,98 times 10 to the power 24. Again, that value is there on your formula sheet, multiplied by 330,000 because that of the sun is 330,000 greater than that of earth, all multiplied by 5,98 times 10 to the power 24, all divided by 1,38 times 10 to the power 9 squared. And that will give me a gravitational force of 413,32 times 10 to the power 24 newtons. 5.3. How will the gravitational force that the earth exerts on the sun compare to the answer to question 5.2? Write down only greater than, less than, or equal to. Give a reason for the answer. Simple. Equal to, because of Newton's third law of motion. If object A exerts a force on object B, then object B will exert a force back of equal magnitude but opposite direction. And that concludes question 5 and hence concludes this lesson. Do comment below on which chapters you want me to do next. But for now, thank you for watching. To support the channel and help more students access free lessons, please like the video and subscribe if you're new to the channel. For additional learning materials and updates, visit our website using the link in the description below. Keep studying hard and I'll see you in the next one. Cheers.